Hello my dear students, welcome to YouTube classes of Unique World Education UAE. So my name is Mohammad Sabit, here I am working as mathematics faculty. So today we are going to discuss about sample question paper that is released by CBSE for the academic year 2024 and 25. Okay, so let's start the discussion of the question one by one. Okay, so we are going to start the question from MCQ part. So the question number one is, for a square matrix A into at J equal to 2025 0 0, then 0 2025 0 0 0 2025. Okay, so they are asking the value of determinant of A plus adjoint of A, determinant of A plus determinant of adjoint of A. Okay, so what I am doing here is just I am rewriting this question. A into adjoint of A is given, right? A into adjoint of A is given. So they are given in this format. From here I can take 2025 outside. So if I am taking this 2025 outside, this matrix will become 1 0 0 and 0 1 0 0 0 1. This will be your matrix if I am taking 2025 outside. Okay, let me take this as some equation number 1. Okay, equation number 1. Now we know the standard identity. We know the standard identity, that is A into adjoint of A into adjoint of A, that will be equal to determinant of A into I matrix. Okay, A into adjoint of A, this is the standard property we are studying in determinants. A into adjoint of A is nothing but that will be equal to determinant of A into I. This you can put equation number 2. So if you are comparing these two equations, A into at J is the LHS part, I is the 1 0 0 0 1 0 0 0 1 identity matrix. So from here, from 1 and 2, the conclusion what we are having, from 1 and 2 I can write easily, determinant of A is nothing but that will be equal to 2025, determinant of A equal to 2025. So first part I got. So determinant of A equal to 2025. Now the second part we want to evaluate, adjoint of A. Adjoint of A, determinant of adjoint of A. So determinant of adjoint of A of order n, you can written as determinant of A to the power n minus 1. This is also the property. So where n is the order of the given matrix. So determinant of adjoint of A equal to determinant of A to the power n minus 1. N is the order of the matrix. So in this question, if I am observing, this is a 3 by 3 matrix, so order is 3. So here determinant of adjoint of A, that I can written as determinant of A. Determinant of A I already calculated here, 2025. So 2025 whole to the power n minus 1. N is 3. It's a 3 by 3 matrix. So 3 minus 1, you will get what? You will get 2. So 2025 whole power 2. That's it. Now they are asking the value of this. So I am just combining these two things. So determinant of A plus determinant of adjoint of A, that will be equal to 2025 plus 2025 the whole square. That's all. Okay, this is option D is the correct answer for this. I hope this question is clear to everyone. It's very simple if you know the basic property of determinants. Alright, now let's discuss the next question. So what we are having in the second question? The second question is, yes, assume X, Y, Z, W and P are, they are given 5 matrices of order. Okay, so let's write the order first. So X order they given, X order of X is 2 by n, order of the matrix X is 2 by n. What about order of Y? Order of Y, it is given 3 by k. Okay, then order of Z we are having, order of Z 2 by P. Then order of W is given, order of W is n by 3, n by 3, and order of P is nothing but P by K. So order X, Y, Z, W, P is given 2 by n, 3 by K, 2 by P, n by 3 and P by K respectively. Then the restriction on n, K and P, so that Py plus Wy will be defined. So we have to define Py plus Wy. Okay, py plus wy is defining, then what will be the restriction on n, k and p? That is the question. What is the restriction of n, k and p? Okay, now if I am observing this question, py, okay, py, it's nothing but matrix multiplication. So p, what is the order of p we are having? That is p by k. So p by k, if you want to multiply with the y is what? 3 by k. 3 by k. This you have to multiply, plus then you want to multiply w and y. So w matrix is nothing but n by 3. You have to multiply with the y matrix, that is 3 by k. Okay, so the basic property of matrix multiplication we know, if two matrices are possible, when the possibility of multiplication happen, the multiplication is possible when number of columns in the first matrix that will be equal to number of rows in the second matrix. So if you are taking p by k, p is the row and k is the column. So number of columns in the second matrix that will be equal to number of columns in the first matrix that will be equal to number of rows in the second matrix. This column will be equal to row. Okay, so here I can write k must be equal to 3. This is the necessary and sufficient condition. Then only py will be defined. P and y we can multiply. Same logic, same concept if I am applying here. N by 3 if you want to multiply with 3 by k, yes, here already we are having 3 equal to 3, no problem at all. So basically py defined now as per the condition when we are giving k equal to 3 and there 3 equal to 3 of course. Okay, so we can directly remove the option k is an arbitrary, then remaining all option if I am checking d also we can remove. So a and c is pending. Now we can understand the question more. Now after multiplication, basically what we are going to do here, we are adding these two matrices. So we are adding py and wy. So py and wy, if two matrices are adding, then we have to say one thing. What we can say from here, if two matrices are adding, then definitely their order will be equal. The order of two matrices are equal, then only possibility of addition will happen. We can add the matrices only if their orders are equal. So the order of this matrix is nothing but p by k, 3 by k, and this second matrix, that is wy matrix, order is n by 3, n 3 by 3k. Okay, so if I am observing order must be equal means rows will be the number of rows in the first matrix that will be equal to number of rows in the second matrix. Number of columns in the first matrix will be equal to number of columns in the second matrix. So if you are observing this 3 by k and 3 by k are equal, so definitely what, this row part also will be equal. So here I can write p by k that will be equal to n by 3. P by k and n by 3 are equal. So here what I can write, p by k and n by 3 are equal. K already we defined, k will be equal to 3. So definitely we can write p will be equal to n as well. So the condition we are having for defining py plus wy, p must be equal to n and k must be equal to 3. That means option 2 is the correct answer. So p will be equal to n and k will be equal to 3. That's all about the second question. So I hope the second question is also clear to everyone. So let's go for the third question. So let's go for the third question. So third question is, let's check. Yes, the interval in which the function f is defined by f of x equal to e to the power x is strictly increasing. Alright, so what interval where the function f of x equal to e to the power x is strictly increasing. So we know the condition of strictly increasing function, that is nothing but f dash of x must be greater than 0. This is the necessary and sufficient condition for a function which is increasing. Okay, so f of x equal to e raised to x is given. We have to find the value of f dash of x. E to the power x derivative is nothing but that is e to the power x itself. So if e to the power x is greater than 0, yes, when it will be greater than 0? So we know e to the power x is nothing but it's a high value function, right? E to the power x is high value function. So if you are substituting any value of x, if you are substituting any value of x, the function value will be always high only. E to the power, if you are substituting 3, 4, 5, if e to the power 0, that is 1 itself, so 1 also greater than 0. If you are substituting negative value also, the function value must be greater than 0. What does it mean? If you are substituting any value, e to the power x is always greater than 0. That means we can say in this interval, which interval? Minus infinity to infinity, e to the power x must be always greater than 0. That means in this particular interval, minus infinity to infinity, the function f of x equal to e to the power x is increasing. Okay, it's a very easy question, basic understanding of e to the power x value only required. Okay. So let's go to the next question. So the next question is, yes, question number 4. If A and B are non-singular matrices of same order with determinant of A equal to 5, then the question is they are asking the value of determinant of B inverse B to the power minus 1 B inverse AB whole square. All right. So how we can write this thing? So they are given determinant of A, that will be equal to 5. The question is determinant of B inverse into AB, the whole square. This is the question, right? So here also we have to know the property of determinant. What is the first property we are using? Determinant of A, B, we can write determinant of A into determinant of B. So here this one I can write determinant of B inverse into determinant of A into determinant of B. I can split all these three. Okay, whole square, this only we want to find. All right, now we know determinant of B inverse, that will be equal to determinant of B, this one, determinant of B whole inverse. Okay, both are will be equal. So here this one I can rewritten as, this one I can rewritten as determinant of B inverse into determinant of A into determinant of B the whole square. Now determinant of B inverse, here this I can write 1 by determinant of B, all right, into determinant of A into determinant of B the whole square. Now divided by B, divided by determinant of B, we can cancel. So we are getting determinant of A the whole square, that's it. So determinant of A already given in the question, that is 5. So determinant of A is 5, then your answer is nothing but that will be equal to 5 square. That's it, very easy question. All right, that's all about question number 4. So now let's go to the question number 5. Okay, so question number 5 is find the value of n such that x power n into x power n into dy by dx, x power n into dy by dx, that will be equal to y into log y minus log x plus 1, where x comma y belongs to positive real numbers, is a homogeneous differential equation. Okay, so homogeneous differential equation condition, basically we know dy by dx is equal to suppose if you are getting lambda power 0 into some f of xy divided by g of xy, when we are substituting the value of x is equal to lambda x and y equal to lambda y, this we can say it as homogeneous differential equation. Okay, so if I am writing this differential equation, try to write this differential equation in this format, dy by dx equal to, this I can write y divided by x power n into log y minus log x, log a minus log b, log of a by b. So log of y by x plus 1 I can write easily. All right, so dy by dx equal to y divided by x power n into log of y by x plus 1. Now this completely nothing, no need to do anything, pure observation. If you are substituting the value of x equal to lambda x and y equal to lambda y, this will become lambda y by lambda x. Lambda lambda we can cancel, it will become lambda power 0. So there is no doubt in this part, this is homogeneous part only. Now y divided by x power n, y if you are substituting lambda y, x if you are substituting lambda x. Lambda if you want to take outside, both have to become equal. The power of x power n and y must be equal. So x power n, of course it will be equivalent to y to the power what, y to the power n. Powers are equal, so it is nothing, implies n will be equal to 1. It's nothing, pure observation. Okay, dy by dx equal to y divided by x power n equal to log of y by x plus 1. So log of y by x, if you are substituting y equal to lambda y and x equal to lambda x, that part is homogeneous. Now y power 1 divided by x power n, if they have to become, if you just imagine, if y square divided by x power n, sorry, y to the power 1 divided by x square, if you are substituting x equal to lambda x and y equal to lambda y, it won't be in lambda power 0 format. Okay, so it is only possible when y to the power what we are having here, that must be equal to x to the power n. So here y to the power 1 we are having, that will be equal to x to the power n power term only. That means n will be equal to 1. It's a very basic understanding question. N will be equal to 1. Okay, so we discussed the first 5 questions of the MCQ part. So the next class also will continue with the same, just go through the 5 MCQ question. So that's all about today. Thank you so much for watching Unique World Education UAE YouTube classes.